Hello, my name is Brandon Verlion. Today I'll be presenting Hero Molecule of the Year, phthalocyanine, which is in the industrial category. And on the image to my right shows its molecule form of it. Some of its physical characteristics for phthalocyanine is molecular weight, which is 514.5 grams per mole. Its physical description is a solid. Its color/form is blue and green color mostly, and is crystalline solid. Its melting point is greater than 300 Celsius. Its boiling point, I couldn't really find a definite answer for it, so I just put N/A. And its solubility in water is metal-free, and most of the phthalocyanines are insoluble in water, except for the ones that have hydrophilic ligand on the metals such as silicon. And to the picture on my right shows a physical form of it, which is including the crystalline solid. Some of its chemical characteristics, though, include a chemical formula which is carbon has 32 of it, hydrogen 18 of it, and nitrogen 8 of it. In air, it's very stable with ambient light including with it. I couldn't find no evidence on it being toxic, so it's not toxic at all. Its flammability, it gives off irritating or toxic fumes, especially in a fire as an example of it. Its molecule shape or symmetry is aromatic, and its blue-green heterocyclic compound, which includes 4 fused benzene rings with it. Its molecule's twin brother/sister, which is a metalloid forms, refer to compounds of those rings which incorporated in an element. And to the right, it's an image of the compound, which includes nitrogen and hydrogen together. And yeah, that's its chemical characteristics for this one. And in this slide, it's some of its history and industrial information. The fame, which is like how it got popular, the copper form was accidentally made in 1927, which researchers are actually trying to make phthalocyanine, but phthalocyanine dyes were widely used for decades. Some of its molecules benefits includes its valuable use to electronic properties. It's very compact and it's pretty reliable when it comes to computers. It comes to any technology, which also includes chips, has data on it, and it really benefits any kind of technology. And some of its drawbacks could be its very high usage rate, and it can be overused, and it can be dangerous. With that being said, it's pretty beneficial. Some of its molecules that perform a similar function to phthalocyanine would be porphyrin, copper, or different metal types, because they're all metals, and they can perform its similar functions of that. And its class of molecules would be tetrayl molecule. Its creation and distribution for phthalocyanine, it was founded in Grangemouth, Scotland. Some of its origins includes the Switzerland researchers discovered the copper phthalocyanine and different kinds of the similar molecules of it, phthalocyanines, and they were very enormous. It had good stability, and it had a lot of dyes and that were included in Scotland that they found. And it wasn't until 1934 that Sir Patrick Lindsten characterized the chemical and structural properties of iron phthalocyanine. It doesn't really come from a lot of sources. It mainly comes from Scotland, where they found it. So it's pretty rare, to be honest. And it's really complex, and it's really rare to find and to use. And there's not that many countries that really use phthalocyanine, but it's really beneficial to those who have it. And yeah, and to the picture on my right, it shows blue dye of it and the phthalocyanine. Why is phthalocyanine a hero? To me, it's presented as or nominated as Molecular Hero of the Year because it's a very reliable macrolocinic compound, which is a type of solid metal that is very useful in helping create new technology with its molecules. It exhibits superior electrochemical catalytic performance due to their large conjugated structure. It has extremely large surface area and is very stable with no evidence of any poison or toxicity. It can't really harm humans or animals. It can be made and used in different ways, such as chips and computer programming. Traditional uses of phthalocyanine, such as blue and green pigments, can be mainly used for automotive paints and printing inks, as blue and cyan dyes for textiles and paper. And to the picture on my right, it shows another pigments of the phthalocyanine, which can be turquoise and it can be dark blue, but mainly it's those colors that. Yeah. And these are just my citations for my whole presentation and what data I used to help me find and help me present this project. Thank you.